Hello, welcome to this video. So this problem is worthwhile for us to discuss. So this problem is quite atypical. It's not a very typical problem in stat exam, in paper 1. So about factorization. Whoa, this one is about factorization. Well, this one is really conceptual. So for part A, so you can see that actually for those able students, okay, if the students they have very clear mindsets, okay, about that they have very good concepts, okay, in factorization, they can really do these two parts by just writing down the answers by observing it. But here many of the other students will be having problems. How to write down or even how to begin with? No idea, because the problems, the question here is so atypical. Well, anyway, so we have I seldom mention the question now. So here for part A, write down all positive integers m. So first of all, m is positive integers, and then n is also another positive integer, and then such that m plus 2m would have m plus 2m equals 5. Now, so 5 is actually a relatively small positive integer, and then m and n will be two positive integers, and then the sum, well, of course, okay, m plus twice of n will be equals 5. So that's why the combinations are quite limited. So that's why here we can start from m equals 1. Let's see when m equals 1, what would that be? So if m equals 1, then so 1 plus 2n equals 5, and then 2n equals 4, so that's why n equals 2, which is also a positive integer. Oh, that's good. And then what if m equals 2? So and then 2 plus 2n equals 5. 5 minus 2 is 3, and then so 5 minus 3, and then so that's why 2n equals 3, so that's why n equals 1.5. Oh, it's not okay. Not okay. And then you just try to continue, and then actually it will be more efficient, okay? It will be more efficient for us to tabulate the answers, actually. Put all these pairs in a table. So 5 minus 3 is 2, so 2n equals 2, so that will be n equals 1. Well, that's good, because we need n to be positive integer. So up to here, we try to tidy up the things first. So these are all positive integers, and this is not. So we then continue. So 4 plus 2n equals 5, and then 5 minus 4, so that will be 1, and then n equals 0.5. So you can see it keep decreasing. So you will foresee that the next n will be 0. So, and then it will go negative. But we want positive numbers, not just integers. We want positive integers. So that's why here, you can see that based on all these trials, so of course all these trials can be done in your mind. So that's why here mn, the two ordered pairs, can either be 1 2 or 3 1. So that's why m equals 1 or 3. And that's why the question wants us to write down the answers directly. Okay, so and then for part B, so the question wants us to find the values of all k such that we have this identity. So the left hand side is the expanded form. Will be a quadratic expression, and then for the right hand side, so there will be 2x plus m times x plus n. And here we just try to expand it. And then group the terms. Just group the x terms. Okay, so, and then for the left hand side, there will be 2x plus 5x plus k. So, and then here we try to do some highlighting. And you can see that, well, m plus 2n equals 5. And then mn equals k. But surprisingly, wow, m plus 2m equals 5, the red highlighting, whoa, we did it in part A. So that's why you can see the two parts are actually related. They are related. So that's why here, for what values of m and n would lead to the sum of m plus 2n equals 5? So we can make use of the answer from part A. Okay, so that's why here, k equals to mn. So we try to make use of the ordered pairs, okay, in part A. So that would be either 1 times 2 or 3 times 1. So that's why k can either be 2 or 3. So actually, you can see this question actually would be related to factorization. Well, if we have 2x squared plus 5x plus k, so where the constant term is still unknown. So for what kind of positive integers k would lead to this quadratic polynomial can be factorized or not? So that's the hidden agenda of this question. So that's all for this problem. Thank you for watching.